So the first thing that I see is that um, I've got the voltage labeled on both of these impedances that it is 5 angle 20 kilovolts RMS. And so I can use that to find the current through these. So I'm going to call this one I1 and this one I2, and I'll call this Z2, and I'll call this Z1, and I'll call this Z source. So Z source is going to be 3 plus J2. And now if I look at Z2, so if I look at Z2, I can see that my power is 5,000, and my angle, I can get that from the power factor. It's leading, so it'll be negative. So my angle is going to be negative, leading, so it's negative, inverse cosine of the power factor, which is 0.9. And so if I'm not, to save time, I'm not going to show you any of the calculations that I already have done, but if anybody wants to check them, that would be very useful because, as you know, if you've spent any time with me, I make lots of calculation errors. So I get that the power for impedance 2 is 5,000 angle negative 25.84 degrees. Now I also know that power is going to equal the RMS voltage times the conjugate of the RMS current. So I can get the RMS current, so, and I'll put this V2 and I2. Well, I know what V2 is. V2, they're in parallel, so they all have the same voltage. And so I2 conjugate RMS equals S2 over V2 RMS. And we just found S2, so, I mean, we have S2, so I2, we found, yeah, we have S2, yes. So we have I2 RMS conjugate equals 5,000 angle negative 25.84 degrees divided by V2 RMS, which is 5,000 angle 20 degrees, which is 1 angle negative 45.84 degrees, which, if you change that to rectangular, is 0.697 plus J 0.717 amps. So that is, well, that's actually, it's minus is I conjugate, and so I RMS, take the conjugate of it, is 0.697 plus J 0.717 amps, which is 1 angle positive 45.84 degrees. Okay, so now I can look at Z1, I think. Let's see. Okay, so I know that, so at Z1, the power factor is 0.85, and so our phase for Z1 is the inverse cosine of 0.85, and so our phase for Z1 is 31.79 degrees, and that's positive because this one was lagging, so we got the positive value. And then from that, I can get the phase of the current for Z1, because I know the phase for Z1 equals the phase of the voltage at 1 minus the phase of the current at 1. And so the phase of the current at 1 equals, bring that over there, so that'd be 20 minus 31.79, and that equals negative 11.79. I can also get the magnitude of at Z1 by using the average power, because I've got the average power. The average power is 10 kilowatts, and that's from the given. So the average power is 10,000 watts, and I know that the average power equals VRMS. Now these are magnitudes, so I don't have the angles here. VRMS, IRMS times the power factor, and so I have 10,000. That's go back and look at our formulas. So that's this one right here, and notice that one I don't have the angles on here, so but I got the angle just a minute ago, so that's okay. So VRMS is 5,000, IRMS, that's what I'm looking for, and my power factor is 0.85, and so IRMS, and this is for 1, IRMS 1 is 10,000 divided by 5,000, and then divide that by 0.85, and I get 2.353 amps. And so now if I write it completely with the magnitude and the angle, I2 or I1 RMS is 2.353 angle negative 11.79 amps. So I just did those for Z1 and Z2, did them in a slightly different way, so you could see that. And then from that, I can just use old-fashioned KCL to get I source, the current through the source, has to equal I1 plus I2. So I source has to equal I1 plus I2, has to equal 1 angle 45.84 plus 2.53 angle negative 11.79. And if you add those together, and I have it, my answer, I have it here in rectangular, I have it as 2.997 plus J.237 amps. Okay, so now if I change that to polar, I get that I source equals 3 angle 4.52 degrees. And then, since if I look at my circuit, well, I shouldn't be using Word. It doesn't work very well with the drawing. But I know that the voltage right here is 5 angle 20. And so if I find the voltage drop across this impedance right here, I'll know what the voltage is at the source. And so I can say that the voltage at the source, I'm going to switch over to OneNote. So the voltage at the source has to equal that the voltage over on that other side, which was 5,000 angle 20, plus the voltage across that impedance, which will be IS times the impedance there, or 5,000 angle 20 degrees, plus that current that we had, which was 2.997 plus J.237 times the impedance, which is 3 plus J2. And at this point, I hope that you're all good at using your calculators for doing complex numbers, because you don't want to have to spend a whole lot of time doing this by hand. And you get 4707 plus J1717, which is the same as 5010 angle 20.04 degrees volts. And so that is Vs, and it is RMS because everything we've been doing has been RMS. And so the problem asked us to get the complex power supplied by the source. So now we're ready to do that, because the complex power supplied by the source, SRMS, is VRMS, IRMS. And we have both of those things. So we have 5010 angle 20.04 times IRMS was 2.997 minus J.237, and that equals 15063 angle 15.52 degrees, and that's VA. Now to get I should have done IRMS conjugate, yes. Yes, I did do IRMS conjugate, I just didn't label it as IRMS conjugate, thank you. Yeah, this needed to be IRMS conjugate, and IRMS conjugate would have the minus in there. Thank you. We know that the power factor will be the cosine of 15.52. That's a positive angle. So that's lagging, and so our power factor is, if you find that cosine, it's 0.96 lagging. And so our overall answer is that our complex power is 15 angle 15.5 kilo VA at a power factor of 0.96 lagging. So I'm going to pause for a minute while I plug in my computer and wait and see if y'all have any questions, or see if anybody finds out what mistakes I might have made. Sure.
For the complex power, it doesn't have to be the process sign convention.
What do you mean by
Because
that?
like the IS is going right now from the negative to the positive.
Is it labeled? Was it labeled in the original problem? Let me
I think so. I don't know if that is.
let me see. Yeah. So let's see. No, my I was going from the negative. Oh, it was, wasn't it? But that would be. Let me think about it for a second. Okay, we just have to hope I don't run out of power. We can either have video or we can have power. It doesn't do much good for me to be working it and y'all don't get to see it. Okay, so let me think about your question here. There's an outlet back here, but I don't think there's one behind me. There's not. I mean, I can make it work. It's not going to be a big issue. I guess, let's see, I guess it's implied because it says, that's it. Okay, all right, so the question was a very good one. Like, don't we have to worry about the passive sign convention? Because the way the current was drawn was into the negative side of the voltage source. So if you go back and look at the voltage source, you see that this was the direction I had the current. And so you would think it would be negative, and it would be, except it says find the power supplied. And so if I'd put the negative in, when I say power supplied, I never say negative power supplied. I either say power is negative, and I don't say it's supplied, but if I'm answering the question, what is the power supplied, I always give the positive value.
Okay, so us changing IS to negative wouldn't change
What you would end up with is you would end up with the power would be negative, okay, but then if you are answering the question, what is the power supplied, you would then you would say the positive answer. So like this would be usually that is what you want anyway, is the positive value. So if you'd used negative, then you would have gotten negative 15. I'm not exactly sure. It would be the negative of the rectangular. So I'm not. You would have gotten you would have gotten. What does the negative do? Brings it in, changes it, changes the angle. But then you would want to change it back. So I usually just go with the positive anyway. And so if I had this, if I had this as in magnitude and angle, then that's what I would use right there as the positive value. Other questions? Any other questions?